Hello, welcome to section 8.6, day 1. We're going to be working with exponential decay functions. In 8.5, we worked with growth. Here are the answers to the word problems that we worked with 8.5, day 2. You'll notice here in this equation, they use 600 and then they put million. You're going to get the same answer down here regardless, just so you're aware. If you put 600 million, if you put 600 million there, you're going to get the same answer, just so you guys are aware. All right, as I mentioned, we're going to be doing exponential decay functions today. So not much is going to change here, except for the b value today is going to be smaller than 1. It's going to be a fraction, such as 1/2 or 3/4 or 1/3, something like that. Otherwise, it's the exact same lesson. So here was yesterday. The growth rate was 3. A can be a fraction always. This is just a vertical shrink. This has nothing to do with it being growth or decay. It's the b value, this number right here, the 1/4. So yesterday, this was multiplying by 3 times 3 times 3 times 3, and here you're going to see it dividing by 4. You could also say it's multiplying by 1/4. That would be another way to describe it as well, multiplying by 1/4. All right, so when we have growth, the graph goes up from left to right. When we have decay, what you're going to notice is the values are going to shrink. And as x gets larger, the values are going to get closer to 0. Versus yesterday, when x got smaller, it got closer to 0. So write a rule for this function. So we're going to take a look at our start value right here. That's our starting value, which is 1. And then what's happening is it's dividing by 5, which is the same as multiplying by 1/5. So you're going to put 1/5 there to the power of x. You won't ever use a division sign here in your equation. You always use multiplying. Make a table of values for this function here. So we're just going to plug in some values and see what happens. So we're going to start with 0. 1/2 to the 0 power is 1. 1/2 to the first is 1/2. 1/2 squared is 1/2 times 1/2, which is 1/4. Now as I go backwards, I have 1/2 to the -1. So we're going to use what we learned in 8.3 with the negative exponents. We're going to flip around our fraction, and that's going to make it positive. So that's going to be 2. Then if I go over here to -2, 1/2 to the -2 is going to be 2/1 squared, which is 4. And you're going to notice the values are going to get bigger as x gets smaller. So 0, 1, 1, 1/2. And then this is going to get basically really, really close to 0. And so we're going to show it not crossing the axis there and draw our exponential curve there. And basically all these are the same problem. I'm going to do this one right here with the vertical stretch and the reflection here. So I'm going to start with 0, plug in 0. I always like to use -2 as well. Okay. Plug in 0. 1/2 to the 0 power is 1 times -3 is -3. Plug in 1. 1/2 to the first is 1/2 times -3 is -3/2, which is -1.5. Plug in 2, we have -3 times 1/4, which is -3/4 or -0.75. And then let's go to the negatives now. -3 times 1/2 to the -1, that'd be -3 times 2/1 to the positive 1, and that gives me -6. And then let's do one more number. Let's do to the -2nd. So that's -3, 2/1, flip that fraction to the +2. This would be -3 times 4, which is -12. And then we can plot those points on our graph. So 0, -3, 1, -1.5, 2, -0.75, -1, -6. And I'm going to stop there. Actually, I might be able to get -12. Let's see, 6, 7, 8, 9, 10. I'm just going to estimate there is -12. And I'm trying not to cross that x-axis there. All right, so just as yesterday, or in 8.5 day 1, we have vertical stretches, vertical shrinks, reflection. So the negative causes the reflection over the x-axis. The 1/3 would be a vertical shrink. The 3 would be a vertical stretch. And we didn't see any translations up or down, but we know what those look like. Here are the homework problems, and just as last assignment, for these here, just tell me the type of transformation. And that's all there is for day 1. Thank you guys for tuning in to 8.6.